Elimu TV High School Mathematics. I am your TV mathematics teacher, Mr. Kamau. In this lesson, we are going to cover the Form 4 topic, Transformations and Matrices. This lesson, we started on this topic in our previous lesson, and we went as far as enlargement. In our previous lesson, we covered the other three transformations, which are reflection, rotation, and translation. For translation, we saw that you have to represent the translation by a translation vector. And that vector is written as a column vector, which in itself is a matrix. And then we saw that the movement of an object under a translation is that all the points move the same distance and under the same translation vector. So if you consider the figure or the diagram of a square, all the points on that square will move through the same translation, such that if you have the coordinates of the vertices of the square, you can be able to tell by applying the translation vector what would be the image of the object, or vice versa. Then on rotation, we learned that the distance of the object from the center of rotation is the same as the distance of the image from the center of rotation. We also learned that every point on the object rotates through the same angle. For rotation, you must mention the angle of rotation, the direction of rotation, and center of rotation for you to have described that transformation fully. Then on reflection, we learned that the image distance is equals to object distance. The mirror line is an angle bisector of any line connecting any line, the any line and its image. And then we also learned that any point that is on the mirror line is its own image. Now, having said that, I want us to move on to today's area of thought, and that is enlargement. Now, for us to fully describe an enlargement, we have to mention the center of enlargement and the scale factor of the enlargement. Let's take, for example, that the point C is the center of enlargement, and we have an object A, B, C, and D. Supposing we give it an enlargement of scale factor 2, scale factor positive 2, so we will have the image A prime, B prime, C prime, and D prime. Now, I hope you can see from my sketch that if you consider the center of enlargement, object point, and image point, you can see that they are all, the three of them are all in the same straight line. Take center of enlargement, the object point B, image point B prime, they are in the same straight line. And that is the first property about enlargement. We say that the object point, its image, and the center of enlargement are all in the same straight line, or they are collinear. We use the word collinear. The center of enlargement, object point, image point are collinear. That is a very important property, especially when it comes to scale drawing. The other thing about enlargement is that the center of enlargement is the only point that remains fixed unless the scale factor of enlargement is 1. If the scale factor is 1, of course we have the object points and the image points coinciding, and therefore we have the other points will also remain fixed. But any other scale factor, the center of enlargement is the only point that remains fixed. Property number 3, for any point A on the object, OA prime is equals to KOA. In other words, if we take this distance, that is the distance we are calling OA prime, and we take this distance, I want to call the center O. So if we consider the distance OA, what is the relationship between the two distances, OA prime and OA? You find that OA prime is equals to KOA, where K is the scale factor. For example, in our diagram, K is equals to 2. K is the scale factor. So, in other words, to get the distance OA prime, that is the distance of the image point from the center of enlargement, you have to multiply the distance of the object point from the center of enlargement by the scale factor. And that is a very important property that we use to determine or to do scale drawings when we are asked, we are required to draw the images or the object. Now, I want to qualify K, because K, the scale factor, when it comes to enlargement, is very, very important. Now, there are 3 conditions. First of all, when K is greater than 0. If K is greater than 0, the image will be on the same side of the center of enlargement as the object. It will be on the same side of the center of enlargement as the object. And you can see in our diagram, actually K is greater than 0. Our K is 2. And therefore, you can see that the image is on the same side, is to the left, to the right of the center of enlargement, so also is the object. How about if K was less than 0? What would happen? If K was less than 0, then the object and the image are on the opposite sides of the center of enlargement. And I will illustrate this. Supposing I had drawn K is equals to -2. The scale factor is -2. So I will have the center of enlargement O there, and I will have my object square is there, A, B, C, D. But because the scale factor is negative, when it comes to drawing the image of of this, I will measure this length, distance, OA, and then multiply it by 2 and move in the opposite direction, and I will have my position A prime. The same with D. I will measure OD, then say OD times 2 will be the distance OD prime. There we are. So I have D prime. And so it will be with all the others. So I will have my image like that. So that this will be C prime and this will be B prime. Now you can see that the object is on the right side right-hand side of the center of enlargement, the image is on the left-hand side of the center of enlargement. So this means that when the K is negative, or when K is less than 0, then you find that the object and the image are on the opposite sides of the center of enlargement. Thirdly, the last one is when K is equals to 1. When K is equals to 1, the object and its image are congruent, or they are on the same position. So if K was equals to 1, we'll find that you have the image coincide at the same position as the object. And that is what I had said earlier, that in enlargement, the center of enlargement is the only point that remains fixed, except when K is equals to 1. When K is equals to 1, you find that A also remains fixed, B remains fixed, the same position, C remains fixed, and D also remains fixed. I hope you have understood that. It's not very complicated, and I'm sure you are following. So that's why I use diagrams when I'm teaching, because it is easier to understand when we use diagrams. Now, we are remaining with only one property concerning enlargement. And what is it? If the linear scale factor of enlargement is, when I talk about linear scale factor, I hope you will understand. What I mean is this: linear scale factor is the same thing when we talk about scale factor. If this length, the distance from O, the center of enlargement, to the point A is 2 centimeters. So if the linear scale factor, which is equals to K, the scale factor of enlargement, is equals to 2, then the distance OA prime, this distance will be twice. So it will be equals to 2 times 2, the distance of OA, which will be equals to 4 centimeters. If OD was 2 centimeters, so OD prime will be 4 centimeters. If OB was 3 centimeters, OB prime, this should be B prime. B prime. So OB prime will be 6 centimeters. If OC was 3 centimeters, OC prime will be 6 centimeters, because the linear scale factor is 2. Now, enlargement is not just about lines or squares or triangles. We could also have 3-dimensional objects. We could, for example, enlarge a cube. We have an enlargement for a cube. And we choose a center of enlargement and make maybe multiply by 2, so that you have now a bigger cube. Then the center of enlargement will be there. So all these points, the vertices, will be the same straight line with the center of enlargement. Now, let's think about if the linear scale factor here was 2, such that, let's say this cube was 1, 1, 1. Okay? The length is 1, width is 1, and height is 1. And let's say we multiply by 2. We multiply by 2, we enlarge it by a scale factor 2, so this will be 2, the length will be 2, 2, 2. So what will be the volume of the cube? The volume of the cube, the image cube, will be 2 times 2 times 2, it will be 8 centimeters cubed. Whereas the object, the volume of the object will be 1 times 1 times 1, which will be 1 centimeter cubed. So now we can talk about volume scale factor. Volume scale factor will be volume of image divided by volume of object. And this will be 8 centimeters cubed divided by 1 centimeters cubed, which is equals to 8. Now look at that. The linear scale factor LSF was equals to 2. But the volume scale factor is 8. So what has happened to 2 to make it 8? We simply cubed. If we cube 2, we get 8. So we can now write down the property, the fourth property about enlargement. And here it is. If the linear scale factor of enlargement is K, the area scale factor will be K squared. And the volume scale factor will be K cubed. So when you enlarge by K, scale factor K, if it is a square or a triangle, its area will be squared, will be the square of the first one, of the object triangle. If it was a volume, it was a three-dimensional object, like a cube or a pyramid. When you enlarge it by a scale factor of K, the volume will be enlarged by a scale factor K cubed. And that is very, very important to note and to remember. Now, I'll just go to one question because of time regarding what we have covered so far. We have covered translation, reflection, rotation, and enlargement. Let me take a question on translation. You are given that a point P is translated by a vector -3, 4. Remember we said the translation vector is written in column vector form. To a point Q, it is translated to a point Q whose coordinates are 6, 5. So you are told, find the coordinates of P. Now to find the coordinates of P, we know the formula that we use. We say P plus the vector, the translation vector -3, 4, gives us Q. And Q, we must write it in vector, column vector form, so 6, 5. So that means, supposing the coordinates of P are xy, then we have xy plus -3, 4 is equals to 6, 5. Therefore, x will be equals to -3. I mean, x plus -3, x plus -3 is equals to 6, which implies that x is equals to 9, and y plus 4 is equals to 5, which implies that y is equals to 1. Therefore, the coordinates of P will be 9, 1. We'll continue with more similar questions regarding transformations, reflection, rotation, translation, and rotation in our next lesson. For today, I was your mathematics teacher, Mr. Kamau. You can reach me through Elimu TV. Thank you and God bless you.